Okay, here's the final video of the semester. Okay, so I want to talk about this coffee cup problem as a system of first order ordinary differential equations. So here we'll let x of t be the temperature of the room and y of t be the temperature of the coffee cup. We want to solve the system dx dt equals 0, and dy dt is minus 3 times y minus x. So it's a little bit artificial to include this dx dt to be 0, just as that x is a constant. But it might be sort of relevant. Maybe the temperature of the room is increasing because it's it's in the morning when it's getting hotter as the day goes on. But anyway, we'll just deal with it, okay? So we're gonna have the initial conditions, x of 0 is 20, the temperature of the room is 20 degrees C, and it stays 20 degrees C because dx dt is 0, and the initial temperature of the coffee cup is 90. All right. So I'm gonna write this as a system in vector form, dx ddt of x, y is going to be, well, let's not write it as a matrix quite yet. We have 0 and minus 3 times y minus x. And I can write this in matrix form. Here's 0, 0. And then what gets multiplied by x? 3. And negative 3 multiplies the y. See that? So this is, the first component is dx dt, which is 0 times x plus 0 times y, 0. dy dt, second component, is 3x minus 3y. And that I can see that by distributing the minus 3 here. Plus 3x minus 3y. So we have the matrix A is 0, 0, 3, minus 3. We want to solve ddt of this vector is that matrix times the vector with those initial conditions. We'll leave those there. So, step 1, find the eigenvalues, find the eigenstuff, eigenvalues and eigenvectors of A is 0, 0, 3, negative 3. All right. Well, lambda, by the way, since this element here is 0 above the diagonal, the eigenvalues are the diagonal entries. Okay? And I could easily, let's just show that to you. The determinant of A minus lambda I is the determinant of minus lambda 0, 3, minus 3 minus lambda. So it's minus lambda times minus 3 minus lambda equals 0. So lambda equals 0, or lambda is 3. Did I do something wrong? I guess so. No, lambda is negative 3. If minus 3 minus lambda is 0, then lambda is negative 3. Good. So it's the diagonal entries. All right. So, what are the eigenvalues, eigenvectors? So lambda 1, we'll call that lambda 1, and that lambda 2. Lambda 1 is 0. So A minus 0i v1 equals 0 vector. So there's our A. So let v1 be AB. So we get 0, 0, 3, negative 3, AB equals 0, 0. So we get 0 plus 0 is 0, and we get 3a minus 3b is 0, okay? So this equation is true, but it's redundant. You know, sometimes we say that the second equation is always a multiple of the first, but that's not the case. First one is a multiple of the second, right? The second multiplied by 0, but basically we have a equals b, okay? So we get, we'll call that 1. You can call it anything you want. That's a b. So we'll let v1 be 1, 1. It's probably the most natural choice. Okay? So we have lambda 2 is negative 3. We have a minus lambda 2I is a plus 3I, which is going to be 3, 0, 3, 0. V2 equals AB satisfies. Well, if I multiply that, I get 3a plus 0 is 0. And I also get 3a plus 0 is 0. So basically, a is 0. Right? So V2, and this can be sometimes a little bit confusing. A is 0, so V2, so B can be anything. We'll make it 1. All right. So that's step 1. Hopefully we'll remember that. Let's summarize the eigenvalues and eigenvectors. Lambda 1 is 0. V1 is 1, 1. Lambda 2 is negative 3. V2 is 0, 1. All right, how you doing? So step 2, write down the general solution. And that's going to be x and y are going to be c1 e to the lambda 1 t e to the 0 t times v1 1 1 plus c2 e to the lambda 2t minus 3t times v2 0 1. Okay. And e to the 0 is e to the 0 t is 1, but we can handle that later when we do it. So step 3 is apply the initial condition. So x of 0 is 20, y of 0 is 90. So from the initial condition we get, from the general solution we get x of 0, y of 0 is equal to c1 times 1, 1 plus c2 times 0, 1, setting time equal to 0 here. And we're going to set that equal to 20, 90. We get 2 equations and 2 unknowns. C1 plus 0 times C2 is 20. And then C1 plus C2 is 90. So this says that C1 is 20. This one says, combined, it says that C2 is 70. All right. So then I have to plug those back into here, and we finally get the solution to the initial value problem. is that x and y are 20 times 1, 1, because either 0t is 1 for any t, plus c2, which was 70, times either minus 3t times 0, 1. Okay. Okay. So it's probably a good idea to write that in terms of the two components. So in other words, x is equal to 20, and y is 20 plus 70 e to the minus 3t. Right? So the room temperature starts at 20, stays 20 forever, right? And the coffee cup, okay, is the temperature of the room plus 70, the initial temperature deviation from the room, times the decaying exponential, right? Okay, so we sort of flogged that horse. I think it's been dead for a while, right? So but it's been fun going through this course with you. Good luck on the final, and good luck with your stay at home. Bye.